Welcome to the third lesson in our trigonometry unit. We are talking here about angles in standard position. And with this unit, there's a lot of terminology and vocabulary that you need to learn. Our goal here is to be able to draw an angle in standard position and determine the principal angle, its related acute angle, and some coterminal angles. So lots of new words maybe that we need to talk about here. So first of all, we need to understand what it means to draw an angle in its standard position. So here are some key ideas outlined right here. The x-axis is referred to as the initial arm and defines 0 degrees. So down here I have a grid, and this, let me just outline that in blue, this could be the initial arm for our angle in standard position. It's the starting spot of our angle. An angle in standard position can be measured from the initial arm to what's called the terminal arm. Terminal means to end, and the terminal arm is where the angle ends. The vertex of the angle will be at the origin. So this will be where our vertex is right here. So let me write that in here. This is called the vertex. This is called the initial arm. Initial arm of our angle. And angles are measured counterclockwise from the 0. So this would be representing 0 degrees right here. If we go in a counterclockwise motion by 90 degrees, we would be up here. If we go counterclockwise a full 180 degrees, we would be over here. And if we went a full 270 degrees, we would be down here. And then 360 degrees is actually what we call coterminal to 0 degrees because it shares the same terminal arm. Coterminal, co means to work together with something. If I measure angles in a clockwise direction, then we say that they're negative. So if I go negative 90 degrees, negative 90 degrees is the same as positive 270 degrees. 180 degrees is the same as negative 180 degrees. 90 degrees would be the same as negative 270 degrees. So that's going in the clockwise motion there. All right, now our principal angle, again, that's another word we need to make sure that we know. The principal angle is always defined as an angle measured from the initial arm to the terminal arm and the angle will always be between 0 and 360, meaning it is going, because it's between 0 and 360 degrees, it is going in the counterclockwise direction. Counterclockwise. So we have an example here where we're going to sketch theta. Theta is just our Greek letter for our angle that we don't know, of 120 degrees. So I already have my initial arm drawn in there. I'm going to draw the terminal arm. 120 degrees would just be 30 degrees more than 90 degrees, which is a third of the way to the 180. And that was supposed to be a straight line. Let me try that again and see if I can draw a better straight line. That doesn't quite look 30. One more time. Third time's a charm is what they say, right? Well, there we go. Let's go with that. So this, in this direction, so I've got my arrowhead pointing there, that is my angle theta, which is 120 degrees. That is a principal angle because it goes in the counterclockwise direction. It is between 0 and 0 and 360 degrees. All right, there are these things called related acute angles. So related acute angle, it is the angle measured from the terminal arm to the x-axis within each quadrant. So in our diagram here, this arm that we drew in for our angle, that is called the terminal arm. The related acute angle is the angle that that terminal arm makes with the x-axis. So if I look at this little angle here, an acute angle is always between 0 and 90 degrees. So this angle that I've marked in yellow here is definitely between 0 and 90 degrees. And if I think about its value in this case, determine the value for the related acute angle, I know that all the way over from positive x to negative x, that's 180 degrees. So if I take my 180 degrees and subtract my principal angle of 120, that would give me that this angle in here is going to be 60 degrees. So my related acute angle is 60 degrees. So for this, sometimes I use the shortcut or short form of RAA for related acute angle, or RAW. That was really obtained by taking 180 degrees and minusing my principal angle of 120 degrees, and that got us 60 degrees there. Okay, and that's our angle of reference. When we go to state our trig ratios for that particular angle of 180 or 120 degrees, we actually will look at the related acute angle and work with that. All right, moving on here. We have coterminal angles. So coterminal angles is another vocabulary piece that we need to know. These are angles that share the same position of the terminal arm on a unit circle, where x is the number of full revolutions or rotations here, full circles. So I have, this example, for example, if I had a principal angle of 100 degrees, I could add 360 to it, and that gives me 460 degrees. If I take 100 and subtract 360 degrees, that gives me negative 260, which is also coterminal to 100 degrees. So really what that's saying, and I'll just do a little sketch in here. I didn't leave any room for this, but I'm going to try and squish it in here. Okay, 100 degrees would be here, roughly. I did that too many times. There we go, 100 degrees. So there's 100, a little less than 120, 100 degrees. If I want to look at coterminal angles, I'm sharing that same terminal arm. So I'm going to start actually with the negative angle. If I were to take and go clockwise around and stop here, I know that my related acute angle in here, if that's 100 degrees, this would be 80 degrees for my related acute angle. So I could look at this as being 180 plus another 80 degrees, which gives us negative 260. Or I could say start at this terminal arm at 100 degrees and go around one full revolution, but in the clockwise direction. So I'm going 100 and then I'm turning a full revolution, 360 degrees, but in the clockwise direction. And I get to the negative 260. Similarly, the 460, let's see if I'll do another quick sketch of this. So here's my 100 degree angle again, 100 degrees. The 460 really says, well, wait a second, I'm going to take this and I'm going to go around a full revolution, 360 plus the extra 100, and I'm going to stop here at that terminal arm, and that's where 460 comes from. It's for the full 360 revolution plus the extra 100 to land at the terminal arm. So hopefully that makes sense what coterminal means. And I could just keep going around as many times as I want. The key is that I have to stop at the 100. So that's where this plus 360 times x. X is just the number of times you want to, number of full circles you're going around before you stop at the 100 degrees that you have here. All right, so we're going to determine the first two negative coterminal angles to 120 degrees, as well as the first two positive coterminal angles after theta equals 120 degrees. So really all I want to do is I want to start with my 120 degrees, and if I want to go around in the clockwise direction, I'm going to subtract 360 from it. So 120 subtract 360 gives me an answer of negative 240 degrees. Okay, which really is my 180 plus the extra 60 when I go around the opposite direction. Then I could go around again in the negative direction, so I'm going to take that negative 240 degrees and subtract another group of 360. So subtract another 360 from that, and we get negative 600. So negative 600 would also stop at that same terminal arm. Or I could take 120 degrees and add 360 to it. So this time I'm at my 120 that I was at before. But if I add 360, it just means I'm going to go around one full time and then do my stop. So that's going to give me 480 degrees. And then I could also add another 360 to that 480. So I'm really going around twice. And for 480 plus 360. I'm really tired and I don't want to make a mistake here. That is going to be 840 degrees. All right, so that one means that I'm starting here, I'm going around and around, and then I stop. Okay, so 2 full revolutions. That's really the same thing as 120 degrees plus 2 groups of 360 degrees. Okay, that's also 840 degrees. So hopefully those words make sense for you and you can understand how to get those. So let's put that into practice on on the other side. For each of the following angles, sketch the angle in standard position, state the value of the principal angle, state the value of the related acute angle, state all coterminal angles that lie within this interval. So we don't want to go below negative 360. We're just going to keep subtracting 360 from the original angle until we aren't in the domain anymore in this value for my theta or my x. And then we're going to add 360 to it until I can't add 360 anymore to be within that particular limit. All right, so 30 degrees. 30 degrees is going to just start and be 1/3 of the way to 90 degrees. There's my 30-degree angle. That is my principal angle. So for part 1, I've got my sketch in there. Part 2, the principal angle is going to be 30 degrees. It's the same as the angle I actually sketched there. The third part, my related acute angle, is also 30 degrees. It's the angle that that terminal arm is making with my x-axis. And the fourth thing, I'm going to take my 30 degrees and subtract 360 from it to go in the negative direction. So that's going to give me the angle that, let's get a different color here, that's going to give me the angle that goes around and stops at the terminal arm here. So that would be negative 330 degrees. That's what we've just drawn in there. So that equals negative 330 degrees. If I tried subtracting another 360 from that, I'm not going to be within my domain anymore. I'll be below that number. I also could have 30 degrees. Let's use a different color here. Let's use red. 30 degrees. I could add 360 degrees to that. That's going to give me 390 degrees. And really what that angle is going all the way around and then going the extra 30 to stop at that terminal arm. So full 360 revolution plus the extra 30. If I tried adding another 360 to that, I'm going to be beyond the domain, I believe, of 270 there. I mean 720, not 270. Okay, so try the next one. Draw your angle in standard position, 160 degrees. Okay, 160 degrees is 20 degrees off of 180. So there's my 160 degrees, starting at the positive x-axis. 160 degrees. That means that my principal angle is 160 degrees. It does lie between 0 and 360. My related acute angle is the angle it makes with the x-axis, so that's 20 degrees off of the 180. My related acute angle is 20 degrees. That's really 180 degrees minus 160 degrees. And then to get coterminal angles, we can just add and subtract groups of 360 here. Okay, so the only coterminal angles that lie within the domain that's been specified up here would be negative 200 degrees and positive 520 degrees. Try the next example, put the video on pause, try it out, and then check your work. Okay, so a negative angle has to go in the clockwise direction, so I went 45 degrees downwards from the x-axis. My principal angle always has to be between 0 and 360, so I drew that in blue here. It's got to go from the positive x around to the terminal arm. That's 315 degrees as my principal angle. The related acute angle is just positive 45. Acute means it's just between 0 and 90, so ignore that negative sign, but it is that angle that it makes with the x-axis. And then I just added groups of 360 to that negative 45 to come up with my 2 coterminal angles to that one. All right, hopefully that's making sense. Try the last 3 examples here and then the very last example on the sheet, and you can check your work on the next video.